And in today's session, we'll discuss about the Ohm's law. Ohm's law. Okay. So, before studying the definition of the Ohm's law, let's know the definition by a diagram. Let's know the definition by a diagram. So, what I do is, I will take a conductor. I will take a conductor. I will take a conductor. I have taken a conductor. Okay. And to this conductor, I have connected a battery source. I have connected a battery source. And this is positive and this is negative, the voltage V. And I have taken a conductor. To this conductor, I have connected a battery source. To this, after connecting a battery, the current will generate. This is current I, which flows in this conductor. I have taken a conductor. To the conductor, I have connected I have taken a battery source. After this battery source, after taking a battery source, current has been generated. Clear? Now from this diagram, what we can say? See, now by using a battery, the current, some voltage has been created here. Due to this voltage, the current also has been generated. Now what will happen? An electric field also will be created. What will happen? An electric field will be created. Yes or not? Yes, electric field will be created. Now, if you observe the diagram, what we can say? Can I say that voltage and current are directly proportional? Yes. Voltage and current are directly proportional. If I am increasing the voltage, if I am increasing the voltage of your battery, definitely the current also will increase. If I am going to decrease the voltage here, the current also will decrease. So, by this scenario, I can write V is directly proportional to I. V is directly proportional to I. So, if I remove this directly proportional, then I will get a constant V is equal to IR. That is what? V is equal to I into R. Yes or not? So from this, what the statement we can say? Ohm's law states that, what we can say? Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. The voltage across the conductor. The voltage across the conductor is directly proportional to the current flowing through the conductor at constant temperature. At constant temperature. I think by this diagram only you can learn the Ohm's law. Simple. I have taken a conductor. I have taken a conductor here. To a conductor, I have connected a battery source here. To a conductor, I have connected a battery source. And due to this battery source, nothing but the voltage, because of this voltage, the current has been generated here. The electrons will be everything that will be. But here, because of this voltage, the current has been generated and electric field is established. Then whatever the voltage that is, that will be directly proportional to the current at constant temperature. Now the direction and this electric field flows from higher potential to the lower potential. Yes, we have studied this point. Electric field will flow from higher potential to lower potential. Means higher point to lower point. Higher point to lower potential, or highest position to lowest position. Highest path to lowest path. So electric field always flows from higher potential to lower potential. Remember this point, very important. Electric field always flows from higher potential to the lower potential. Clear? Yes. Now, Now electric field is established by connecting a battery and current also produced here. Now the electrons, how these electrons moves, in which direction the electron moves, we have to know. So already discussed about this. The electrons will move in the opposite direction. From the last 2 to 3 classes we are discussing about this. Electrons will produce in the opposite direction because electrons are which charge? Electrons have which charge? Electrons have negative charge and proton has positive charge and neutron will have the neutral charge. Neutron will have the neutral charge. Now what happens? Now we'll see that how this electric field will have impact on the electrons. How this first point is, I have connected a battery. First point, I have connected a battery. Due to this, an electric field is established. That was clear. And electric field direction also we know that flows from the higher potential to the lower potential. We know the direction of electric field. And the fourth point is how this electric field will have impact on the electrons. How this electric field will have an impact on the electrons. Means impact here, the meaning which says about the impact is the direction. The direction. Electric field always will keep a force on electrons. Electric field, this point is very important. Electric field will keep force on electrons. Force on electrons. So can I say F is equal to Q into E bar? F bar is equal to Q into E bar. Yes or not? For every object, a force will be existed. A force will be created. Clear? Yes or not? Force will be created. In this way, this electric field will say the electrons to move in the opposite direction. Force, which means electric field is moving in this direction, electrons are moving in this direction. Clear? Here a force has been existed. I'll show the example also. You'll get very clear cut idea of that. But the fourth point is electric field will always keep a force on the electrons. Then the electrons move. Then without keeping any force, how can I move from here to here? How can I move without applying any force? In the same way, in this scenario, electric field will keep a force on the electrons to move. Simple. Electric field is saying that electrons to move. How? It is applying some force. So that I can write in a formula like F is equal to Q into E bar. Q into E bar. Now, already have said that about this also. If V increases, I will increase. If V decreases, I will also decrease. Which is directional proportionality, directly proportional. So that's why V is equal to IR. So we'll write here R is resistance. We'll write for these units also. Units are very important. So R is the resistance, V is voltage, and I is the current. Simple. The units for voltage is V, I is ampere, resistance is ohm. We'll write the symbol ohm. The symbol for ohm is this one, ohm. Now F is equal to Q into E bar. Now which force has, on which the force has been created? Electrons. Electrons are which charge? Negative charge. So can I write from this equation, can I write F is equal to minus E into E bar? Can I write? Yes. Because we know the formula for Q is equal to N into E. As electron is a negative charge, I have to take minus. So can I write F bar is equal to minus E into E bar? Can I write? Yes, I can write. Next, electrons will have negative charge. So from overall this, we'll talk only about 2 points. We'll make very clear of 2 points. The first point is that electrons are moving because of. The first question is that electrons are moving because of what? From this diagram, electrons are moving because of which parameter? Because of what? And the second question is that because of what? Two becauses. Electrons are moving because of something dash, and these are moving because of dash. If you know this single statement, Ohm's law is very easy for you, and you can solve any theoretical or any numerical problem also. Clear? So I will tell the answer for this. I will explain this also. My question is that electrons are moving because of. We have to know the reason. Electrons are moving because of electric field. Electrons are moving because of, very important, electrons are moving because of electric field, and this electric field is because of potential difference. Because of potential difference. How that potential difference has got? By connecting a battery. Because of potential difference. Clear? So electrons are very important statement. Electrons are moving because of the electric field, and these are moving because the establishment of electric field because of the potential difference. Because of the potential difference. Now my question, one more question is that now electric field has been produced. I'll write EF. Okay, I'll write electric field for you again. If electric field increases, not electric field first. If V increases, if voltage increases, what about the electric field will also increase? What? Because of potential difference, because of the voltage only an electric field establishment has been done. Yes or not? Yes. So that's why if V increases, electric field also will increase. Electric field also will increase. Remember this point? If V increases, electric field also increases. Because of that V only, an electric field has been established. And electric field has been established. Clear? Now, so can I write a formula for like this? E is equal to V by L. You will study in the electrostatics this formula very clearly. E is equal to V by L. I think this point was very clear for you. The statement was very clear for you. Electrons are moving because of the electric field. Because of electric field. And because of electric field, because of potential. Why I am repeating this statement continuously? There is so much meaning in this statement. Though so much meaning is statement mein chupa hai. If you understand this statement, you can understand all the physics very easily. The current electricity, highest scoring subject. Marks also you can get more marks in the current electricity. Clear? So because of voltage, I have said a single statement. Because of voltage, electric field is created. Why? Because electrons has to move. We have studied from here now. हम ऐसा ऑर्डर में पढ़े थे अभी तक. So let's move into the reverse order also. Let's move in the reverse order also. So because of voltage, electric field is created. Don't confuse. Because of voltage, electric field is created. What this electric field is doing? It is making the electrons to move in the reverse direction. Yes or not? This is what we say. You observe this diagram carefully once. Observe the diagram. Observe this diagram. According to Ohm's law, what did I say? Voltage is directly proportional to the current at constant temperature. Voltage is directly proportional to current at constant temperature, which means if voltage increases, current also will increase. If voltage decreases, current also will decrease. Clear? So, and the one more point what I have said, because of voltage, because of voltage, electric field is created. Because of voltage, electric field is created. Clear? Yes. So next point is electrons movement. This was clear in the last slide. This was clear. Now, if you observe here, so this is, enjoy this animated diagrams because for a student, if he study continuously also, sometimes he can remember, after some time he forgets. But when he study with respect to some picturization, some visualization, the brain accepts very easily. Yes or not? If you I think the people who you watch a movie with very some intense happiness, you watch, will have a full-fledged concentration on the movie. After 10 days, after 1 year, after 2 years also ask, who is heroine? You will reply, you will give an answer immediately because of picturization there. So, while preparing for the exam also or any subject, picturization is very important. So, that's why you people, what you have to do is make the short notes in a colorful way with some diagrams. Make the short notes of yourself. Make some mind maps also. If you prepare the short notes in that way, you can easily remember, you can easily recollect everything. Clear? So, study with respect to some picturization, some visualization, it will be quite easy for you. It's my suggestion. Clear? Observe this diagram. This diagram says about the Ohm's law. So, whatever the theory I have said up to now, that is one extent. Observe the diagram carefully. You can see that the statement is V is directly proportional to I. V is equal to Ri. Ohm's law. Yes or not? V is directly proportional to I. This is voltage. This is voltage. And this is current. And this is resistance. Clear? Before that, in this diagram, already I said a force has been created and the electrons move in the opposite direction. Clear? And if you observe here, from one end to other end, the electrons are moving continuously. Yes or not? Is there a possibility that from here, suppose 100 electrons has passed from here. Here also 100 electrons has to reach. Is there any rule? No, there is no rule. Because whatever the resistance that is there, that opposes the flow of electrons. Some electrons will be opposed by some force. Some electrons will be opposed by some force. Listen carefully. Some electrons will be opposed by some force. So that is known as resistance. Opposition of flow of electrons is known as resistance. Once again, opposition for the flow of electrons in a conductor is known as resistance. So, for the definition of the resistance, Now we'll write resistance also, then I'll elaborate that diagram. Resistance means opposition for the flow of electrons. Simple. Is known as resistance. So from there many electrons are coming and some of the electrons are opposed. So that is known as resistance. Opposition of electrons is known as resistance. Clear? Now, observe this diagram. According to Ohm's law, if voltage increases, current increases. Yes or not? If you observe the diagram, the voltage is pushing the current to go. Pushing the current means here the electrons. What are the charge carriers in the conductor? Electrons. Now the protons are the positive charge. Charge carrier means electrons. Don't confuse with the word. Charge carrier is something that charge carriers here is electrons. The voltage is pushing the current to go. But if you observe here, the resistance is pulling upwards, opposing the electrons not to go. Observe it, see. It is pushing, but the resistance is pulling. Yes or not? It is doing some opposition here. So this is Ohm's law. That's all. Observe this. This is green is voltage. See, this voltage is sending the electrons continuously here. Nothing but electric field is sending continuously the current. Now see what happens. The resistance, what it is doing? Suddenly the width has been reduced, which means it is opposing the flow of electrons. See how it is going. See here. Now this voltage, the electric field is sending the electrons. Now what the resistance? What the resistance is doing? It's pulling. Nothing but it is opposing the flow of electrons. It is opposing the flow of electrons. Observe the diagram carefully. Observe the diagram carefully. I think this was clear for you. So this is also the same Ohm's law. Observe the diagram. So I'll write the statement here. I'll write the statement of Ohm's law. The voltage of a conductor is directly proportional to the current flowing through it at constant temperature. At constant temperature, the voltage across the conductor is directly proportional to the current flowing through it at constant temperature. At constant temperature, the voltage of a conductor is directly proportional to the current flowing through it. So can I write V is directly proportional to I? Yes. From there V is equal to I into R. R is a constant value. So R is resistance. Clear? Now we'll make some relations. So can I write R is equal to, from this V is equal to R into I. From this R is equal to V by I. We'll check now whether this resistance depends upon the voltage and the current, or only it depends upon the voltage or it depends upon the current. We'll check that. So according to the Ohm's law, if V increases, definitely I also will increase. According to Ohm's law, if V increases, what happens to I also will increase. If V decreases, I will also decrease. Clear? Yes. Because it has the relation of directly proportional. If I increase the V here and I also here, what will be the ratio for that? It will be same or different? Definitely it will be same, because V is directly proportional to I. So from this scenario, can we say that resistance depends on the voltage and the current or does not depend? Yes, resistance does not depend upon the voltage and the current. Very important statement. Why? Because if a concept question or a theory question comes, if he has given in this way, like if he give the definition for statement 1, if he give the definition, and the statement 2 he says that resistance depends upon the voltage and resistance does not depend on the voltage and the current. Clear? And one more statement is that electrons flow in the direction of electric field. If these three statements given, answer the which of the following are true. If they have given the statement like this, what we have to do? To answer this question, we have to know the concept. Clear? I'll make one statement question also like that. So from this relation, can we say that resistance depends or does not depends? Yes, from this statement I can say that resistance does not depend upon the voltage and the current. Voltage and the current, because of the Ohm's law property. Ohm's law states that voltage is directly proportional to the current. So, a note point I'll write here. Note point. Resistance does not depend on voltage and current. Clear? Yes. So all these are very, very important points. Next, we'll write the definition for the resistance. Resistance means, I'll write a simple definition. Opposition for the flow of electrons is known as, so this is the definition. Opposition for the flow of electrons is known as resistance. What are the units? Ohms. So it is denoted by the letter, see the symbol, it is denoted by the letter there. Next, the units of resistance are ohm. Clear? Next. So one more point also we can write here. One more note point, this is, with respect to this I am writing note number 2 here. If voltage increases, then current also increases. If voltage doubles, current also will double. If voltage increases, current also increases, then the ratio of resistance will be this is for you. If voltage increases, see, check there, if voltage increases, current also increases, and the ratio of resistance will be same or different? It will be same. Very important. Clear? So we have studied till now the Ohm's law, the definition, the condition, what happens if the voltage and current increases, what is the role of resistance and definition of resistance, and the units of resistance and the symbol and the resistance ratio. So finally we can say that resistance does not depend on the voltage and the current. Clear? So next what we do is factors on which resistance depends. Factors on which resistance will depend. We'll check that. Just have a glance of this diagram. This diagram, clear? So next, did you observe the diagram? This one also. Voltage is sending the electrons, the currents to move continuously. But the resistance, what it is doing? It is opposing the electrons. Don't go. It is opposing. It is making some break here. Don't go. Clear? So that is Ohm's law. That is Ohm's law. Very simple. So next we will discuss about the factors on which the resistance will depend. Factors on which the resistance will depend. Clear? So this is the resistance. See, the voltage, the electrons, the resistance. See this diagram also carefully. What it is doing? It is opposing. It is stopping the electrons. So in electric field, we'll say opposition of flow of electrons is, we say as resistance. The same way studying the magnetic field also, we'll say as their reluctance. See, that's what in the first class already I have said. The concept is same everywhere. The concept everywhere in each and every subject is same. But the terminology we use, that is different. So from this, what you can think? So every subject is easy. If you know the concept, every subject is very, very easy. Clear? Observe the diagram. Voltage. What it is doing? Electric field is moving from higher potential to the lower potential. Higher potential to the, I have connected a battery here. Okay. Electric field is moving. This is electric field. And electrons are moving in this direction. These are the electrons. Electrons are, these are electrons. Negative charge. Now, from here, the electrons are moving. But what the resistance is doing here, it is stopping. It is opposing the electrons flow. Yes or not? So that is known as resistance. Opposition for the flow of electrons or opposition for the flow of charge carriers is known as resistance. Clear? Now we'll see the factors. Factors depends on resistance. Resistance depends on which factor? Factors depends on the resistance. So, resistance, we know resistance, we are saying that flow of electrons, flow of opposition of electrons is known as resistance. Now, on which factor it depends? We'll see that. So, for that, I'll take a conductor again. I'll take a conductor. I'll take a conductor of having some cross section. Clear? This is a cross section of some length L. I have taken again a conductor of some cross section A of the length L. So I'll say this in the two cases. The first case, you think in general way. You think in a general way. Clear? Now I have taken a conductor, this one. Okay. If I take a thick conductor, then what happens? The area will also be more. If I take a thick conductor, the cross section area will be also more. It will be easy. It will be thin. Thin रहेगा क्या? नहीं रहेगा. अगर conductor, if I am taking the thickness of a conductor is more, then the area of cross section also will be more. Yes, not remember this point. Area of the cross section also will be more. If area of the cross section is more, then what happens? Number of electrons. Number of electrons. I'll take two scenarios. See, this is a thick conductor. This is a thin conductor. Clear? First case is I have taken a thick conductor. If it is a thick conductor, what happens? The area will be also more. Yes or not? Yes. First point is clear. If I consider a thick conductor, then the area also will be more. If area is more, the passage of electrons, the flow of electrons also will be more from one end to other end. The flow of electrons will be more from one end to the other end. Then the resistance will decrease. We'll see that also how. Then the resistance will decrease. That's the first case. If now I take a thin wire, see, this pen is a thin wire. If I take a thin wire, the area of cross section also will be thin, very less. If the area of cross section is very less, listen carefully. If the area of cross section is very less, the flow of electrons will be in a rapid way, or it will move it will go with some collisions. The flow of electrons also will be in a lesser way. It will not move very fastly, and the collisions may occur here. If collisions occurs, what happens? Electrons will collide with each other. Clear? As electrons will collide each other from one end to the other end, then the resistance will increase. So, and this all happens in two statements. I have said that it has to travel from one end to the other end, which means it is depending upon the length also. Here the resistance is also depending upon the length. Here the resistance is also depending upon the area. So in the first case I have said, I have taken a more area, then what happens? The resistance will be less, which means here the resistance is depending upon the area, and here the electrons, whatever the position for the flow of electrons, which is resistance, is depending upon the length also, because it has to travel from one end to the other end, because only within specified length I am saying, specified area. Clear? So from these two statements, what can we say? What can we say? What can we say? What can we say? I will say, don't worry. I'm here to say. We'll combine the two statements and we'll write the conclusion point on which the resistance will depend. Very easy. We'll discuss some of the tricks also here. The first condition is consider ethic wire or conductor, then what happens? Thick wire or a conductor, what happens? Area of cross section will increase. Area of cross section will increase. If area of cross section increases, what happens to the flow of electrons? Flow of electrons also will be more. Flow of electrons will be more. So then what happens? Resistance will be decreases. We'll see that also. And the second statement is, consider a thin wire or conductor. Area of cross section will decrease. If area of cross section decreases, the flow of electrons will also doesn't flow. The flow of electrons doesn't move fast. Then what happens? Collisions will occur. Same like a railway compartment. If you go by a general railway compartment, what happens? From one end to other end, you have to go. If you take a general railway general compartment, what happens? many people will there, passengers will be more in the general compartment, but from one end to the other end you have to go. Definitely you have to hit, you will hit, wantedly don't hit, but you will hit because the strength of the passengers is more there. You have to reach the other end. Your aim is to reach the other end. To reach other end, definitely you have to, you will collide with the passengers, you will collide with the baggages, luggages, etc., etc. Yes or not? So there the area is very less because of the passengers. And at the same time here also the area, as the area is very less, the electrons at a time, the electrons cannot move very rapidly. The electrons cannot move rapidly, and it will, and if you want to go rapidly also, definitely collisions will occur. So by combining the both statements, what can we write? I can write that, and it is depending upon the length, both. So resistance, this is also an important point. Resistance depends upon the length. So from this we can write R is inversely proportional to 1 by A, and R is directly proportional to L. So we'll combine this both the formula. So I'll write R is equal to, or R is directly proportional to L by A. Now I'll take the proportionality. So from this I can write R is equal to, after removing the proportionality, I can write rho L by A. Rho L by A. So from this, the formula for resistance is R is equal to rho L by A. This is L. Rho L by A. Rho is a constant here. Rho means resistivity. Rho is resistivity. Rho is resistivity of the material or the specific resistance. We can say rho is resistivity of the material or we can say specific resistance. Terminologies are very important. Terminologies are very important. So rho is resistivity of the material or specific resistance. So from this what we can say, resistance depends upon the what? Length and area. Resistance depends upon the length and area, and it also depends upon the temperature. Why? Because electrons are moving. How the electrons are moving? Because of heat generation. We are giving some heat by use of some battery. Clear? So because of that, the heat generation, the thermal generation will be, because of that electrons can be moving from one end to the other end. So resistance depends upon the temperature also. So it depends upon the 3 parameters. So resistance, note point. Don't worry, I'll give from first lecture to the, I think in the next session I'll give all summary. I'll give everything in a summary view. Clear? That will be very easy while revising for you. So resistance depends upon area, length, temperature and material also. Which type of material we are taking, which type of conductor we are taking, that is also very important. And material. Madam, it is very difficult to remember, madam. How? All the 4 terms is very difficult. We feel very hectic. How to remember? My Huna, I'll give a shortcut for you. So resistance depends upon the area, length, temperature, material. Clear? I think up to here you are very clear. See here. See here once. Just have a glance on this. Just observe it. Yes. So my question to you was, on which parameters, on which factors, on which parameters the resistance will depend on? Option A, I have given as option A. Option A, which one? Material. Option B, temperature. Option C, electrons. Option D, length. Option E, area. Clear? Which of the following are correct? Option A, B, D, E. Option B. Like this I have given options. A, B, C, D. C, D, E. Option C, B, C, D, E. Option D, B, C, A, C, D, E. These are the 4 options. All of a sudden you have to remember it. How can you? If you have thorough practice and if you practice number of times, then you can answer the question. Theoretical questions, yes or not? How can you answer? If you have a good command over the concept, then you can. So, for example, if you have a good command over this concept, resistance depends upon the area, length, material and the temperature. Clear? So, material, yes, it depends on the material, it depends on the temperature, electrons, length, area. Yes or not? So, answer A, C, A, B, D, E. So, option A will be the correct answer. Then, suppose we forgot the concept, then how? At that time, these tricks will be useful to you. This type of tricks will be useful to you. Clear? How to remember? See, just remember resistance of all material. Resistance of all material. I want to know on which factor it depends. So for that, remember the shortcut Tamil. Remember the shortcut for the resistance, that is Tamil. T means it depends upon the temperature. A means it depends upon the area. Mi means it depends upon the material. L is the length. That's all. Done. How was? So like this tricks you have to follow for some of the concepts. Clear? So the trick for the resistance, on which factor it depends, means use the trick Tamil. Temperature, area, material, length. Temperature, area, material, length. See, T, temperature, A, area, M, material, Mi, material, L is length. So use the code Tamil. Clear? Just check it. Just have a glance. Clear? Next. So, I have written that the formula for resistance is R is equal to rho L by A. And the units are for resistance are ohm. Clear? Now, from this, what we can write? Rho is equal to what we can write? R into A by L. Now we have to know the units of resistance also. You have to know the units of resistance also. Yes or not? Yes. This is L. So the units for resistance is ohm. The units for area is meter square or meter? Meter square. Meter square. And the unit for length is meter. Then here 1 meter, here 1 meter will cancel. So I'll get ohm meter. So the unit for specific resistance, the unit for Specific resistance or resistivity. Specific resistance or resistivity is ohm meter. Ohm meter. Clear? So the units for resistance is ohm. The units for specific resistance resistivity is ohm meter. Clear?